everyone. For my current project, I wanted to explore GPS trackers, especially in places where cellular connectivity is not present or very weak. For example, if you go trekking or out for sea trials, kayaking, canoeing. And that is why I decided to explore LoRa. So for today's video, we will explore a very simple communication between two LoRa nodes, just exchanging data between each other, and unlike Wi-Fi and Bluetooth low energy, it will be slightly long range as well. We have to differentiate firstly between LoRa and LoRaWAN. LoRa is just the physical layer or the wireless modulation, whereas LoRaWAN will typically come with the gateway, a server, and the application infrastructure, which will allow all the sensor data or the communication data that we are sending to each node to the internet via the gateway. So LoRa is much more simpler. If you imagine in the OSI layer, LoRa or long range protocol will lie in the lower layers of the OSI, whereas LoRaWAN will be in the network layers and the above layers. So for today, we will be using this LoRa radio breakout board that I got from Adafruit. It is based on RFM95. It is a Semtech module. So I have two of them. And for the firmware, we will be using Arduino LoRa by Sandeep Mistry. Once again, it is not LoRaWAN, it is just using LoRa, the radio protocol. So let me show you the hardware setup that I have. This is what one of the LoRa node looks like. So it comes with the Adafruit breakout board. It is connected to an Arduino Uno board, and it also comes with the antenna. Now I have two of these, node A and node B. If you look at the wiring, we are connecting the SPI buses to a bunch of the Arduino GPIO pins, and we are also connecting the G0 to the interrupt pin of the Arduino Uno via the LoRa breakout board. Now, one thing we have to take note is the frequency of the antenna and the LoRa module that we are using must match. So in this case, the one I bought is 868 or 915 megahertz. And if we look at the general frequencies, there are basically three types of frequency: 433, 868, or 915. So firstly, let's go ahead and detect whether the ports are available. Right now, I have not linked any of the nodes. So let me go ahead and link node A. I will just plug in the USB cable here, and this is node A right here. And now when I query it again, you will see the port number right here. And this is what we will be flashing the Arduino firmware. And similarly, I will go ahead and plug in the node B, which is right here. It has exactly the same setup. And now when I go ahead and query the ports, there are two ports available. So let me just go ahead and copy it and ensure that the port is correct for node B. So for the firmware here, I am going to use LoRa duplex, which is in one of the examples in Arduino LoRa. So I have split the screen here once again. This is node A, and on the right it is node B. The first thing you will notice is that after acquiring the relevant libraries, we have defined the pin numbers, basically the check pin, the reset pin, and the hardware pin. So once again, if you see here, this is how I have wired it up. And you can also see the same here. The MISO and MOSI pins are 6 and 7, which are basically linked to D12, D11. For D1, it is linked to G0 of the LoRa module. So I have to basically make sure that both the nodes have the same thing. Now, after defining the pins, we have to also define the local address and the destination address. So for node A, I'm just going to do it as hexadecimal. Whereas for node B, it will also be hexadecimal, but I'm going to label it as B. Similarly, let's go ahead and do it for destination address, which is going to be B in this case for node A. And for node B, it's just going to be vice versa. So after this, if you look at the firmware code, there are basically 4 functions: the setup and the loop, which is normal for all Arduino firmware code. Finally, the send message and the receive message that the 2 nodes will be exchanging. So let's go ahead and look at the setup function. And for both of them, it's pretty much the same. I'm just initializing the serial and setting the pins and doing some checks to ensure that the LoRa is available. So please ensure that over here, LoRa.begin, the frequency of the module that you're using matches right here. Now things get a little bit interesting in the loop function, because when node A is sending a sensor data or some kind of data to node B, if it is sort of busy doing something else, it will not be able to receive it. So we will use some timing functions instead of delay functions to ensure that both of them are able to receive it in a sort of half-duplex communication. Inside each of the loop function, let's first define the fake sensor data in this case. So I'm just gonna initialize say string sensor data equals to, and I'm just gonna count ++. And right at the top here, I'm also gonna initialize count equals to 0. And finally, I'm gonna use the function send message to send the count. I'm gonna do the same for node B and initialize the count as well. Now you realize that in the loop, there is no delay at all. So before we tackle the timing, let's also do some serial prints. And I'm simply going to print send data, the sensor data, which is the count, from the local address and then the destination address. So I'm going to do exactly the same in node B as well for the loop. You can imagine that without any timing delay, this will be sending very, very fast, and the nodes each other will not be able to receive any of the messages. So we are going to use this Arduino function called millis, which will basically return the number of milliseconds since the program started running. So instead of putting a delay, let's put an if case. If millis, and then we are going to minus it by the last send time. And this interval should be greater than the interval we set. And let's put all of this inside the bracket. Of course, at the end of it, we have to initialize last send time equals to millis once again. Actually, we do need these variables. So I'm going to go ahead and set it to 0. And say interval to about 2 seconds. All right, so now back to the loop function. Instead of setting the interval as 2 seconds every single time, we will add in a little bit of randomness just so that the other node can receive it. So in this case, interval will be random, say 2000 plus about 1000. So this if is where we will be sending about 2 seconds with a little bit of random interval. And now we will also be receiving it. And for receiving, we will use the receive message, and we will simply do parse packet, which is provided by the LoRa Arduino framework. All right, so I am going to copy the entire loop to node B as well, because it's going to be exactly the same. And of course, I have also initialized some variables. It's going to be long. Maybe I'll put the count together with the non-constant variables. All right, so that's how the loop looks like. Now inside the send message, it is really simple. We are just going to write the destination address, local address, the message that we are going to send out, as well as the length of the message. And we will start it with begin and end. Now, receive message is something interesting. We have to start with a lot of checks. So the first check that we will do in the receive message is to ensure that the packet size is not 0. If it is 0, we will return immediately. Next, we will declare some variables such as the recipient address, the sender address, the incoming length, and the incoming message. Now, the incoming message is initially empty, but we need to read it. We need to read it character by character. And after this, we will do some error checking once again. The first error checking that we will do is the length of the message. And the second error checking that we will be doing is the recipient and the local address are not the same. Obviously, you do not want to receive the same packet that you're sending. And finally, we will print some data. For example, the received data, who is the sender address and what is the recipient address. And this function will exactly be the same in node B as well. So I'm just going to copy this entire function and copy it for node B. So there you see, we have initialized some variables like local address, destination address, may ensure that they are opposite. Sorry, the interval here should be about 2 seconds. And then we have the setup. The loop is where we will be doing some of the timing hacks to send it as well as receive it continuously. And finally, we have the send message and the receive message. So we have written our firmware both for node A right here and then node B. And let's now flash in the firmware and see whether they are communicating. So I'm going to flash in for node A. Well, obviously there are some errors. Sorry, of course, I should be sending sensor data instead of count, which is an integer. Change this to a string because send message is taking in string argument. So let me flash it in again. And seems like both are successful and they are to the correct port. So let me connect in the serial console program. This is node A and this is node B. So there you see node A. So let's look at a sending one. So it is sending data 2 from A to B. And yep, it has received data 2 from A to B. So let me disconnect it and clarify. And similarly, it is sending 4 from A to B, and here there should be a received 4. Yep, there is a received 4 from A to B. And similarly, if we do sending data 3 from B to A, there should be a received data 3 from B to A. So that was how the exchange was happening between the two LoRa nodes. A very, very simple communication with no internet, no cloud, just two nodes, peer-to-peer, exchanging some data in a half-duplex way with a little bit of random interval that we injected so that they can both receive and send that seemingly seems at the same time. So it can also be used for battery-powered devices as well because LoRa is a low power protocol as well. So if you need something long range but low power, for example, you want it to last for a few hours, unlike say using cellular, this could also be one of the way. So thanks for watching and play with LoRa if you have the chance.